Hello everyone, and welcome to Automate All the Things, an introduction to Jenkins. Just a rundown for our plan today. We're going to start with an introduction, then we're going to quickly move into describing what Jenkins is and what it's all about. Then we're going to do a little demo on Jenkins jobs and get you all familiar on sort of common approaches to building and deploying and some other neat stuff. Once you've got an idea of how Jenkins works, we're going to discuss some killer plugins that you absolutely need to have. And then we're going to work through some recommendations and best practices and some cautionary tales and worst practices. And finally, wrap it up neatly with some conclusions. Just to start off, as Barry said, I'm Justin. I'm here because I love to give presentations, I love Jenkins, and I love open source technology. I'm a graduate of software development. I worked at CDOT for a year as a research assistant, and now I'm working at NexJ Systems for the performance team, doing automation of analysis and load tests. So I've been in DevOps for about 2 years and interested in software for at least 6. And I'd like to start off today with a quote. This is from a 1920s Spanish poet and playwright, and he says, "Besides black art, or black magics, there is only automation and mechanization." And with that, let's talk about what Jenkins is. So there's a lot of buzzwords going around Jenkins and automation servers and sort of the industry in general. And if you're not deep in it, it can be sort of meaningless to you. So you got to be agile and you got to be lean so that you can implement DevOps automation to get continuous integration, continuous deployment, and continuous delivery goals. And all this stuff that involves circles and cogs. But like Jenkins would and does provide for continuous integration needs. It does fit well into agile methodologies. It is a DevOps tool, and it could foster lean development. But really, if there's anything I could leave you with today, it's that Jenkins, it's just an automation server. That's all it is. I could end the presentation right here, and I would be satisfied, because that is the most important thing everyone needs to take from today. It can do a lot. I mean, it can do automation through Jenkins jobs, so you can build and deploy and test in anything you really want. And because of that, it can support complex processes and pipelines. So if you need to automate a complex process, Jenkins is a great tool to do that, because you can learn quickly with it and get your work done quickly with it. And wraps all this in an amazing access control. So you can give users, you can make everyone who has to use your system have accounts, and you can define what accounts are in what groups, and then what groups can do what things. Who can see what builds, who can control what builds, who can configure builds, and most importantly, where those builds can run, what machines they're allowed to have them on. It also provides amazing out-of-the-box notifications and monitoring support. So if you want to get an email every time a run goes through, or you want to get a ping on your favorite Slack channel when something goes wrong, it's very easy to set up or add. And finally, Jenkins is incredibly extensible. It's got a lot of plugins. It's very modular. There's not a lot that is under the sun that you can't do with it. And sure, as a concession, you can use it for automating your builds and deploys and tests, and it's really good at that, because it's going to let you consolidate the steps of producing, setting up or starting, and then finally testing a programmer's system. But I'm here to say, I mean, it can be used for anything else. It's just an automation server. So say you have to wrap a command line interface tool. What if you're the only person on your team that knows Bash, but you need everyone on the team to use a tool that's been written in Bash? A very quick way to get it accessible to all these members is to just wrap it in Jenkins CI, provide a front end, and then make anyone who needs to use it have an account. Then you can track who's using the tool, and you can give permissions on what they can do with it. It's also great for any sort of complex environment setup you have, given you need it to be quick and across OSs. So say you wanted to give push-button access to a bunch of Docker containers and MS SQL servers, you could do that very quickly with almost no experience with Jenkins. And then finally, if you need to monitor processes, it's another great tool to reach for. If you need to know how a specific tool went every run, and you don't want to create your own cron job that's going to send you emails about its status, you can add it to Jenkins, get Jenkins to schedule it, and then have it do all of your monitoring and emailing when it comes to failures or successes. So just to clarify, it is not just a CI server, because it can do way more. It's not just a fad because it's not going to be going away soon. And in itself, it is definitely not a be-all and end-all because it's totally designed to play nicely with friends. Given all that, where does Jenkins fit into your server system? So it's really meant to be in the middle. Jenkins wants to do everything that humans really shouldn't be doing in your processes, anything that can be automated in your whole software cycle. So a pretty common workflow would be for a developer to push their code to some sort of source code management system, like GitHub, and for Jenkins to pick up the changes. It could then automatically start building a series of Docker containers that has your app and bring them up while simultaneously talking to your database and preparing it for a dry run test. And in the end, it can launch the test and do this whole process automated without the developer really having to say anything. All he has to do is implicitly push to a test branch, and he'll get that. Just a brief history. This is something really funny to me. Jenkins started off as the Hudson project in 2004 under Sun Microsystems. And after Oracle took over, there was a dispute over infrastructure in 2010. Oracle was claiming the rights to a lot of the technology. And so they had negotiations where Oracle gave up and relented on a lot of those rights. But one thing that stuck was they had to claim the right to the Hudson name. And so being a bunch of awesome software developers, they decided to rebel entirely and fork Hudson, creating their very own GitHub project, literally only changing the name to Jenkins. As of 2013, Jenkins on GitHub had 567 project members and 1,100 public repos. And the original Hudson only has 32 project members and 17 repositories. So Jenkins has definitely taken over. Okay, nitty-gritty of what we're going to be looking at in our demo. We're going to be talking about freestyle jobs, approaches to automated building and deployment, and some other fun stuff, on-demand and triggered jobs, and parameterizing builds. Okay, so jobs in Jenkins. Just a quick run through. What is the anatomy of a job? What are they composed of? Well, there's 6 main things. There's general properties, such as the name and description, and a bunch of other boring sort of make sense properties. There's source code management controls. So if you want to pull your code or if you're building something, how you would talk to your repos. Build triggers, when you want your build to go off. Build environment controls. These are sort of like the miscellaneous category, just a drawbag of whatever you want to add. And then the meat and potatoes, which are build steps and post-build actions. And a general workflow would just be to make a job, define parameters for it, configure your properties and source code management if it does exist, define some build steps, and define some post-build actions. And with all that meaningless stuff said, let's do a demo. Okay. So I've got a Jenkins server set up here on my local host. I don't know, is that so tiny that no one can read it? Should I? I'll just make it bigger for good practice. Yeah, so let's start off with a very simple freestyle job. So jobs are the fundamental building block of Jenkins. Pretty much all of your automation is going to be inside jobs and controlled that way. Let's just make a very simple one that we're going to call Hello World. It's going to be a freestyle project. We're going to hit OK. All right, general properties, name Hello World, description, prints Hello World to the console. That's all we want this job to do. We're going to gloss over a bunch of other fun configuration stuff and go straight to the meat and potatoes, which are your build steps. This is where you define exactly what should happen in your automation. So as you can see, there's a lot of options here. You can execute a Windows batch command, execute shell, invoke Ant or Gradle, call Maven. These are all sort of the built-in stuff. And I have a neat plugin that gives me the ability to call other projects, but I'll show that in a bit. Let's just do something simple. Execute shell. By the way, I'm running this off Ubuntu, so if I were going to do execute Windows batch command, that wouldn't make a terrible amount of sense here. So let's just echo Hello World. Can hit apply, save, and now we've made our very first incredibly simple job. If we wanted to run it, all we'd have to say is build now. You'll see build history. It has a new entry for number 1. We can click it. OK, we have a build. It was today, approximately 20 seconds ago. And if we go to the output, we can see all it does is echo hello world and say, hey, nothing exited 0, so I'm very happy. Now let's do something a little more interesting. So I've set up a repository called hello world. And it's a very simple Java program that just prints out hello FSOSS. Let's try and get this built in Jenkins. New item. Let's call it a simple build example. Make it a freestyle project and continue. We're going to skip over the description, and we're going to go straight to source code management. So we want to add a Git repo here. For anyone who hasn't used Git before, it's pretty simple to bind. You just take the HTTPS URL, and you stick it in here. Now I've got some pre-configured credentials here, but it's really simple to add them. You would just click here and give a username and password, or you can configure SSH keys if you're so inclined. And I'm telling it just to watch my master branch. So pull anything you're going to try and build, pull off master. For the triggers, I'm going to do this one manually, so I'm going to skip everything. And I'm going to go straight back to the build steps. So let's do some simple compiling in Java. So for our build steps, we're going to add an SSH command. Something to note is when Jenkins pulls your repo, it's going to create a folder for your job. And it's going to create that in the Jenkins workspace. So all of this code, or these 3 files, will go into the workspace that I'm in. And from the SSH's perspective, I'll be starting there. So what I can do, really, is I know that this hello world.java program will be pulled and will be right in front of me. So I can just do javac hello world printer.java. And that should compile it. And if I wanted to prove that it was working, just call java hello world printer after, and it would run it. Now, assuming I haven't put in any typos, and I don't get demo luck, this build should go very fine. So it's just going to pull, do a javac, create the .class file, and then run it. No errors, thank God. And there we go. It successfully compiled hello world printer and called Java on the class to print hello FSOSS. So that's a very, very simple build. Now say this doesn't really help us because it's not really producing anything. It just demonstrates that it can compile. So let's add the ability to create a jar. For anyone who doesn't know Java, you need a manifest file to create jars. But for anyone who does, I'm just going to say, I've got this manifest file here. And all it's going to do is call hello world printer. So the next step would be pretty easy. All I need to do is say jar cfm. Now I give it a location to put the jar into. I'm just going to put it into temp so I don't have to mess around with any permissions. Say hello world printer.jar. I want to do it using my manifest file. And I want to include all the class files I've compiled here. OK, so logically, it's just going to do the exact same thing as before. It's going to pull hello world Java. It's going to compile it, run it to prove that it works. And then additionally, it's going to jar it up. So let's save this. Build now. Didn't break on me. OK, cool. So it ran the command and it didn't exit 0. Let's prove that that actually exists. Let's go to temp. Let's do an LL. And there you can see it created hello world printer.jar at 12:21. Oh, no, you can't. Of course not. There you go. Now you can see that it created hello world printer.jar. Is it back? There we go. OK. So yeah, I created hello world printer.jar there. And if I want to prove that it works, I can do a java jar hello world printer. And it prints out hello FSOSS, although it's incredibly tiny and no one can see it. There we go. That's a little easier to read. All right, and one last thing. So now we actually produce a jar file, and we can control where it goes. And we're building code uniquely from a repo. So if we want to change this using our Git, or if we want to push changes to this on GitHub, then they'll be picked up by our build, and they'll be automatically put in. Now let's do one last very simple thing to demonstrate how you could use Jenkins in a sort of generic way. And let's add a version parameter here. So jobs can take parameters before they're ran. And parameters are pretty much just variables that you have access to inside the job. So we can create a string parameter here and call it version. The default value, which is going to say x.xx. And for the description, we're going to say a version number that looks like 1.0, or 2.27. It's a very simple versioning system. And the way that we would get our jar to include this version would be very simple. We just do a hyphen. And now we know that we'll have access to the version variable. So we can just do this. And what will happen is everything else will run normally. But when you're jarring up your archive, or when you're creating your archive, it will add this version number before the .jar. So I can hit save. Now when I try to build, it's going to ask me for parameters. I'll say I'm creating 1.01 here, and do a build. It runs. It doesn't complain. If I go to my temp, ll piped into a grep for hello. See, there's hello world printer 1.01. Run it, hello FSOSS. So that's a very simple job that can be created very quickly. Let's look at something a little more exciting. So I've got a very simple Spring app that I've built, and it runs in Maven. This thing was failing circa 5 minutes ago because I couldn't get my internet working. But we can give it a shot in a second. So I don't know if anyone here knows Maven, but it's basically a build system for Java. And it's very simple to define customizations for how it should build things and to define dependencies for what your builds require. So just starting off, I've of course provided a repo URL. If you want to see that repo, it's just right here. It says my Spring app. And I would go in and show you the code, but it's very deep. It's enterprisey, so it's really not worth the time to show you a hello world call. So I've got the repo. And now down to the build steps. So this is a step you guys have never seen before, and it's called invoke top-level Maven targets. It's basically the equivalent to doing execute shell with Maven and passing a series of parameters. But it gives you this very nifty UI for controlling all of the properties of it. And it provides much better errors and sort of much better feedback in terms of what's happening on the Maven side. And as you can see, I just tell it where my pom.xml is, or the Maven-specific file. And I tell it what goals I want to do. So in this case, I want it to Spring Boot, or to build the jar for my Spring application. And then right after that, I do something sort of weird. I copy the built jar to Jenkins home user content. So if I just run this, it's pretty simple. Oh, looks like it's not giving up. Check out the output for this build. There we go, cool. So it was able to connect to GitHub, pull our code, and do a successful compile. So this on its own doesn't really do much, but we can look at a more complicated deploy example and show you how this might be useful. Another thing to note is I've set up Jenkins on a VM on this local laptop, and I've installed it as a slave. So you can see here there's master, which is my main Ubuntu laptop, what you're seeing now. Then you can see local Ubuntu VM. And like I said, that's just a slave. It's a VM installed on my machine that Jenkins can access and control. That's important to note because I limit where this deployment project can run. I say specifically only run it on my VM. So when I deploy, I never want to deploy to my master. This would, for example, represent a case where you only want to build on your master, or you could represent an opposite case where you only want to build on your slaves and deploy to your master. But for the most part, it's not suggested to allow anyone to control the master or to really do a lot of projects on it because it controls your whole Jenkins configuration. So for source code management, nothing, because I'm not really doing anything with source code. And in the build environment, you'll see that there's one step here called copy files into the jobs workspace before building. This is a remnant of the copy artifacts plugin. It's basically what it's going to do is it's going to look on the master and look in the user content folder on the master for any files. And I can tell it to copy a specific file into the workspace for this project, which is going to be running on the slave. The key thing to recognize here is that the slave has no access to the jar on its own. It can't really see it because the master built it and the master kept it on its own drive. What this plugin, which was very quick to install and very sort of simple to understand and use, does is it copies things from the master over to this build before I run it. And so in this simple example, all I do is copy the jar over and run it. So if I do build now, it runs. And as you can see, it prints out hello FSOSS, followed by a bunch of Spring stuff. By the way, Michael, thanks for taking my ASCII word art idea. I thought I was pretty unique, but apparently not. OK, and so let's do one last sort of fun thing here. Say I want to have a build sometimes deploy at the same time, but not always. A very simple way I could accomplish this that's sort of very easy to understand is to add a parameter to my first project. So there's lots of different kinds of parameters, and the one I'm going to be using now is a Boolean parameter. So Boolean just means true or false. Here I can say deploy after build. Default value is going to be false because I don't normally want to deploy after a build, or I might want to just test it normally. And for the description, I would say whether or not to deploy to the local VM after building. Then I can go down to my build steps, and I can add one additional step. Conditional step. So a conditional step goes off depending on a series of conditions. This time we're going to tell it we have a Boolean one, and we're just going to give it the parameter we have directly. So in very much the same way I could use $variable name to access a parameter in the script, I can do the exact same thing here. And then I tell it what to do given this option. So I'll just say, trigger a call on another project. And the project I want to call is my more complicated deploy example. Hit apply. And save. So now if I run it, again, it's going to ask me for parameters. If I click it, there we go. So it's going to ask me for parameters. And I can tell it, yes, I want to deploy after my build. When I hit a build, it's going to run the Maven build, and then it's going to call my other project. And if we click here, you can see something's in the quiet period. And it's done. Check out the console output for this guy. And we see hello FSOSS again. And oh yeah, you can see that it's building on the local Ubuntu VM because it says building remotely on local Ubuntu VM. OK, so that is my demo. That's a pretty simple explanation of how you can get through building and deploying with Jenkins, and sort of some fun things you can do with parameterization and triggers. Now, given all that, there's a series of killer plugins that you're absolutely going to need and you're definitely going to want to know about before you go out into the wild and start playing. So the first one would be I would suggest would be the parameterized job triggers plugin. And that was the plugin that let me set up that optional deploy after build step. And what it does is it lets you make jobs composed of build steps of other jobs. Now, normally, this sort of goes against some Jenkins aspects because you're meant to build workflows or sort of chain projects in a way such that they implicitly call the next ones that are necessary on their line. But I find Jenkins is pretty unopinionated, and you can use it sort of however you want. So if you find it's easier to take your parameters in all at once, or to consolidate your build steps this way, then it's an easy way to allow for the elimination of repetition and to encapsulate all of your functionality. And it's just a lot of fun to use. You can take these complicated workflows where you have to run a test, but really it's going across different nodes and needs to do cleanup before and after, and show it in just like a simple list that you can see in a major project. The next would be another one that I demonstrated, the copy to slaves plugin. This one's really easy to use and just incredibly powerful. If you want to move logs around, or you need to move build artifacts, or you need to get just something from your slaves to your master or from your master to your slaves, it's very easy to use and very essential. Another one that I use frequently, at least at NexJ, is the locks and latches plugin. And it's incredibly good if you have concurrent jobs that absolutely cannot run at the same time. You could set up your schedules so that they automatically don't do that, but say you're not quite sure about it, or you're a little fuzzy, or say if these two database operations run at once, your data set's going to be ruined and it's going to take you 40 hours to regenerate that, then it's good to just have a double back and say, this is my database operations lock. While anything is running that's on this lock, another one cannot start. So you can't have two cleanup operations start at once, or have a cleanup operation go at the same time as some sort of creational operation. Another one that I use a lot is the parameterized scheduler. So it lets you create schedules for your Jenkins jobs that accept parameters when calling them. So the original scheduler plugin only takes a time sort of to start it, but this lets you put in parameters so you can control it. And I know the syntax is really ugly. That's just an artifact of it being cron syntax. So you've got to use your cron notation at the beginning and then sort of define parameters after that %sign. And it doesn't really work very well for individual runs. But oh yeah, and a Jenkins pro tip, if you need something to run on only one day, you can schedule it for just one day of the year and pray that you remember before that day next year to delete it. And then the last, like, absolutely mission critical plugin is the green balls plugin. You didn't see this in my demo, but by default, Jenkins comes with blue balls for success. So when something runs right, it's blue. No, that's just wrong. Like, I can't take that. It needs to be green. The story here is the inventor is Japanese, and in Japan, their original, like, old-fashioned streetlights use blue. And so they eventually changed the blue to green because nobody could see it from a distance, but it was like a vestigial, they kept calling it blue for go. But that just doesn't fly here, and I can't take it. Blue to me means like medium, like didn't break, but didn't go perfectly. Okay, so now that we've talked about all that, let's talk about some recommendations and best practices. The first 5 I'm going to talk about are straight from the Jenkins website, and I sort of went through them and pruned for the ones that I think are best for beginners and for a mass audience. So it's like, these are the ones that are just, if everyone knew them or everyone remembered them and used them, I think we'd all be fine. So the number one that I would say is to always secure Jenkins. If you're going to be using Jenkins, don't just let anyone connect. Don't allow anonymous access. Don't let anyone configure whatever they want. Make sure anyone who needs to use it has an account. Make sure that anonymous users can at best view console output. and make sure that the users that you sign in and sign up have like really well-defined groups and really well-defined controls in terms of granularity. And just make sure everyone can do pretty much only what they need to and nothing more. The next one, this is one that I'm guilty of, and I find it's something that everyone would say they should do, and everyone says is like, you have to do it, but then nobody remembers, and everyone forgets. And so it's like, it's just better to avoid this sort of a headache than to have like 2 weeks of automation just go down the drain and have another 2 weeks of work to get it to go. And a neat thing here is you can actually have Jenkins automate the backup process of Jenkins itself. So you can just make a job that will do that for you. The third would be to take steps to ensure failures are reported as soon as possible. So when I started off, I didn't set up any sort of email notifications or any sort of notifications at all. So when a job, or whether a job went good or not, I wouldn't know. I just have to like monitor my Jenkins and watch it constantly. And that works in development when you know that nothing is really meant to work and that everything's sort of in a half-built state. But it doesn't really work when you depend on it and you need a lot of testing or a lot of building done quickly. So this lets you figure out when something's broken, or even more importantly, I use this to figure out when I was in a deadly loop because we got about 700 emails in about 2 minutes or something. So it's important to do this, and it helps a lot. It's worth it. It's very quick to set up email functionality. I shot myself in the foot by not doing it because it could have taken 2 minutes to get like successful and unsuccessful messages. The second last one is to set up Jenkins on the partition that has the most free disk space. This isn't absolutely necessary, but it's one of those just good practices. It's better to over-allocate than to under-allocate in terms of this sort of project and this sort of system. So this is just something to keep on your mind. Maybe you could separate the workspaces for your projects onto a separate partition than the Jenkins installation itself. There's lots of choices. And the last one, this one's a lot like backup. It's sort of obvious when you say it, but no one really thinks of it. And that's that you should write jobs for your maintenance tasks, such as cleaning up your database, cleaning up your logs, making your environment clinical, so getting it prepared the way it's meant to by restarting services and making sure everything's fresh. This is something that's really valuable that most people forget because they sort of put it into a specific peg for what Jenkins is meant to do. And these are just some personal recommendations. Caveat, these are things that I notice I've been burnt by when I forget to do them. The first one is to enable timestamps. Console logging by default with Jenkins doesn't come with timestamps. They assume your tool will be outputting the timestamps that you want and that you care about. I've had some issues with that, and timestamps can be really valuable because you can tell it to show either the exact time that it happened or the relative time that it got the console output inside the context of the run. So you can see like, oh, this was 5 minutes into the run, this was 10 minutes into the run, so on and so forth. Another would be to make sure to click the option to delete your workspace before builds. This is a great sanity check, and it just really lets you make sure that whatever you're building is exactly what you want, and it's cleanly what you want. And it doesn't include any old artifacts or any old code that will influence your output. And then my last one is just always use locks. Just always use locks. If you have two operations that cannot happen at the same time, I don't care if you're 100% confident that there's no way they could be triggered at the same time, just make sure that they don't. Okay, this is for some cautionary tales, or worst practices. I'm going to lead this section with a quote. If you automate a mess, you get an automated mess. This is said by Rod Michael, who's a director at Rockwell Automation. And Bill Gates said something to a similar tune. It's very true, and it's sort of what this area is all about. And by the way, these are just based on my personal failings where I've made huge mistakes. This isn't based on some list of like the top 20 worst things you can do with Jenkins, because for the most part, you won't be able to find a top list of the 20 worst things you can do with Jenkins. Just no one seems to talk about it. So let's talk about it now. I would suggest avoiding overly long jobs. They can be very unwieldy, very hard to work with. If you make a change, you won't necessarily see that change or understand what it does when you go back to it. And if you forget to save or something happens, it can be really frustrating to go back and clean up the job and get it back to the state it's supposed to be in. Usually, these unwieldy jobs point towards poor factoring of the steps in your automation. So you didn't make small enough atomic steps. It can also point to using Jenkins as a crutch. So Jenkins is very versatile and can do lots of things. That doesn't mean you should build all of your processes into Jenkins using only Jenkins. There might be a better tool, for example, Maven. If you have a complicated Java build, maybe it'd be worth your time to get it running on Maven and then just wrap that Maven call in Jenkins. You get all the same monitoring, but you have a much more robust build-specific tool to depend on. And then I would say, if you're not using Jenkins plugins or functionality, you're just sort of trying to do it your own or build your own hack that gets something done, that's often something that can cause really large projects. And the two simple ways you can avoid this are just by factoring your steps into smaller jobs, making sure each piece is very atomic and does only what it needs to. And then another way, as I said earlier, is to wrap a tool that might be more equipped to the job you're trying to do in Jenkins. My next biggest cautionary tale would be to not reinvent the wheel. Always Google first, everyone. Like, this is Jenkins. It's got a huge community of developers and of users. And there's just all these plugins. So if you have a problem and there's not a plugin that already solves it, there's probably someone else that's done something very similar, if not exactly the same to what you need, on the internet, who asked questions on Stack Overflow, got answers, and got it all put together. Another thing I would say would be to use sane standards in your job naming. You can have lots of builds, and when you sort of get into the automation world and you get into Jenkins, it's sort of like a bug. You start wanting to automate everything and get everything on like push button control. And so you end up creating all these jobs all at once, and you'll have bring up, okay, so example, bring up versus turn on versus startup. This is just arbitrary. They're all different for no reason, and it's going to make it very hard to read and understand your jobs. So unless they have a reason, unless there's a meaning between the three different terms, just pick one and use it everywhere. And also, spaces can be the devil. Be very careful with spaces. Just in your titles, in your descriptions, in your parameters, and anything you're going to be calling or expanding, just be careful with spaces. And then also rename your jobs with care, because sometimes your pipelines will be broken. Sometimes Jenkins can't refactor all of your jobs correctly, or just forget some. And in those cases, your builds will quickly stop working for reasons that you don't really understand until you look at the console and see that it's calling an old job name from months ago that you haven't run in a couple months. Okay, so let's deal with some conclusions here. The biggest one, eat your apples and use Jenkins. Okay, so Jenkins is for automation. It is a complex tool with many purposes and possibilities. It can do a lot, but its main purpose is to do what the humans in your system shouldn't be. If you have an automated mess, that doesn't mean it will get any better with Jenkins. At the same rate, if you've got a human doing a very efficient process, manually, it's the same problem. That's what Jenkins is there to solve. It's not only for CI or building and testing, but at the same rate, it should never be used as a crutch for avoiding better processes that should be wrapped in it. Second, Jenkins is a Swiss Army knife. It is incredibly extensible. It has a huge library of plugins, an amazing community of developers and users. And it plays nice with other frameworks due to this. It's designed to be the glue that fits in between all your servers, all your systems, and gets your whole software cycle on track. And finally, Jenkins can speed your work quickly. It is very quick to learn Jenkins and to get your human beings back to doing human work. And it provides robust modular interfaces for automating, monitoring, and controlling access to this work. So it's very quick to pick up and very quick to get working for you. And I'd like to leave with one last quote from Larry Wall, the original author of Perl. He says, there are three great virtues of any programmer: laziness, impatience, and hubris. And I think with a little of all three, anyone can use Jenkins in the way it's meant to and see serious value with it. Thanks, everyone. I should also mention, NexJ, my company, is hiring. If you're interested in seeing an opportunity at a fun Java enterprise company, give them a call and make sure that you say Justin Flowers referred you. Okay.
And Raj, okay, I can tweet that out as well?
No, not you. Not you. Unless they say Justin referred me.
Yeah, NexJ's been a great employer for Seneca, actually. A lot of grads. Grace Batumba, yeah? Is he?
Oh, Grace. Yeah, Grace is still there, yeah.
Seneca alumni.
He's a manager now.
And he was the first, correct me if I'm wrong, Don's our chief, first BSD graduate? Is that?
Yeah.
BSD graduate to work for NexJ. So that was about 4 or 5 years ago. We did an alumni video. So lots of
paved the path for me. Yeah. That's what he did.
That's awesome. So
anyhow, more about me.
Yes. So I think it's about Q&A, from what I understand. So
yep. Any questions?
Questions?
Andrew?
So in your demo, you showed automating builds using schedules and by clicking buttons. Mm-hmm. But how easy is it to make it hook into a GitHub repo to specifically do a build when changes are made to the repo?
So there's 2 ways you can approach that. You can either schedule polling for a repo, so like watch this repo every X amount of hours or minutes and get changes. Or you can set up what are called GitHub hooks that will basically call an endpoint on your Jenkins server when there's a change to the source code, and it will tell Jenkins, hey, there's been a change, start this build, pull this code. I didn't demonstrate it here because that's a little more confusing, and it's a lot more going into GitHub and configuring like endpoints and settings there. But there's like a million tutorials on it, and anyone can really do it. It's sort of slow and not really worth it for tutorial purposes. But it's very simple to have it builds triggered on changes to code bases.
Can I ask a follow-up question on that?
Yeah, sure.
So the thing is, those hooks that are on GitHub, can they be kept private?
Not positive about that. I believe so. I'm not sure about access control in terms of the GitHub hooks.
Because you could have your hooks written in the GitHub repo itself, which could send it to your. Yeah. I think there is.
Oh no, it's not. It's not. You set up hooks for the settings of your account and for different repos, but all it does is in the settings for that repo, it sends a request to your endpoint, right?
Yeah, so your Jenkins server URL, it's publicly accessible and it sends a HTTP host.
But that can be seen by anybody who sees
your endpoint, yes, but you can add security for that. You can have it so that not just anyone can ping your endpoint.
It's in the settings of your repo. So if you're the owner of the repo, you can see it.
Like I would go through it, but really you can just play around with your own. When it comes to security, sure your endpoint has to be accessible, but you can make it so that only only GitHub is the one that can actually like talk to your thing or like at least validate with your thing.
Yeah, I got it.
Okay, cool. Sorry, you've had your hand up?
Is it possible to have Jenkins jobs on the source control?
Yeah, there's a series of, it's called the Groovy scripts that allow you to basically call your jobs from what looks like a scripting language or like Java. You can definitely do that. I'm sort of a person, my opinion is that you should probably keep your builds and your processes out of Jenkins in terms of anything that's so complex that you would want a language around it. So I would suggest maybe putting it into Ant or Ansible if you have that complicated of a workflow, but it does provide a very nifty system for controlling Jenkins itself through the source code. And that's the Groovy build scripts if you're interested. Any other questions? Michael?
So you didn't really talk too much about the infrastructure of how you set up Jenkins, but I was wondering, is there a distributed kind of nature to the Jenkins master? You said that if the master goes down, you're kind of...
Oh, you're kaput, yeah.
Right? Is there any, like, if the master goes down, you can elect a different master to then handle it based on the nodes you have in your Jenkins infrastructure?
So I'm not positive about that, but I imagine if it doesn't come out of the box, then there's a plugin that will allow you to do that. You can set up lots of different slaves and lots of redundancy in terms of what to do. What to do when the non-master node goes down. But from my experience and from what I've done, you really want to lock down the master node and make sure that it's very safe. So I don't know. Maybe I'll have to get back to you on that one. All right. If there's no other questions.
And on behalf of the FSOSS organization group, here's a little present for you.
Thank you.
And